My name is Baumann from Jacobs University, and I'm exploring the world as well, now going backward and forward. Hey, it works. I don't need to introduce array database because Yang has just done a great job in doing that. So I want to go forward. Okay, brief history. Array databases, how did that develop? For a long time, it was difficult to sell that to people that it's something useful to do arrays in the database. Meantime, we have quite some of them. We try to collect them. It means first appearance when we found them. It does not mean when implementation started. Typically, there were concepts first, concept papers, and then implementation started. From those players that we find around now, there are two classes mainly. The one see arrays as attributes, and this is the majority of the systems. And then we have two, so to say, exotic systems that see arrays as tables. That's SciDB and Cycle, as we have just seen. We fit into, well, I will show you later on. What have we done? Well, we've been researching into raster services, large-scale services, and going beyond that recently. One main outcome was the Rasdaman system, standing for Raster Data Manager, and that has brought me into standardization in the Open Geospatial Consortium. Now I'm leading the working groups for the raster geoservices, and notably we have there a raster query language standard already, the WCPS. And there's a recent activity where we are involved talking about array SQL capabilities. A spin-off company is there to support where the university cannot give support, so we are doing that together. But now coming to EarthServer. EarthServer is a European initiative, about $7 million US budget, where we have 11 partners that want to do scalable, on-demand analytics and fusion for the earth sciences specifically. So what does that mean? We have the different earth sciences, each one represented by one partner here, like EOX doing snow and ice cover with European, the ESA, European Space Agency data. NASA is doing the same thing with in situ high-flying drone data. Atmospheric sciences, that is 3- and 4-dimensional climate data. Geology, so subsurface model, British Geological Survey. Ocean is handled by Plymouth Marine Laboratory. That's mainly in situ, mainly ocean models and also satellite imagery. And then we have something exotic, Mars geology, so to say. We want to find out where there is water below the surface of Mars. The common engine underneath is the Rasdaman system. And what we are doing there technology-wise is we are looking into federated query processing so that atmospheric science can spawn a subquery to ocean, integrated data and metadata search, and visual clients like 3D over the web. That gets me to Rasdaman. So what we have done, we have looked into something that can support sensor, image, model, and statistic data. The result of looking into application domains was a minimal and safe and declarative algebra, which is the basis for the model. We wanted to implement that in a minimally invasive way into classical database systems. So Rasdaman extends a standard system with a column type that is an array, having a cell type and having an extend. Now, this is embedded into standard SQL, into a DML with array operators, and that can be used for quite a few purposes. But I want to go behind the curtain. Tiled array storage, partitioning is something that every system does. There's no way around that. The regular case is also called chunking, and that's what most systems do. We also support arbitrary storage in sub-arrays, and we have several strategies which help the database designer to find the appropriate partitioning, mainly a storage layout language, for example. Query processing is very much standard. If you look into the SQL parse tree, you find a set tree, and we don't mess with that one. So we leave standard SQL intact. And on the element tree, we work with our array operators and add them. And this is what we also optimize then, and we have a tile-based optimization. So tile streaming allows us to deal with large objects while always keeping just 1 or 2 tiles in main memory. Not always, but often. Federation, we skip that. Oh, credit is given. Yeah, I can read it. Michael Ovonibi, that was his work. Peer networks, I call it. we have peers. Every peer can receive a query. And if it finds out that it's better to spawn it off, then it's sent to another server, which answers that and goes back. And with that, actually, see you at the poster. Does that ring a bell with you?